This is section 15.9, problem number 15 in Calc 3. All right, so we're doing a double integral over the region of x minus 3y dA. The region and xy plane are bounded by the points 0, 0, 2, 1, and 1, 2. And the transformation was x equals 2u plus v, y equals u plus 2v. It is a linear transformation. Okay, so 0, 0, and xy, put 0 here and 0 here. Anytime you get something like this, then the ordered pair in u and v is also 0, 0. You can tell just by plugging in that it works. So 0, 0, and xy becomes 0, 0 in uv. How about 2, 1, and x and y? Put a 2 here and a 1 here. So you multiply the top equation by 2, 4 equals 4u plus 2v. And then you can subtract this equation minus this equation, 3 equals 3u. That gives me u equals 1, which means v equals 0. So the point 2, 1 becomes the point 1, 0 in u and v. And finally, 1, 2. 1 equals 2u plus v, 2 equals u plus 2v. Again, multiply the top equation by 2. It gives me 2 equals 4u plus 2v. Subtract this equation minus this equation, 0 equals 3u, u equals 0, which means v equals 1. So the point 1, 2 in xy becomes the point 0, 1 in uv. All right, so in the uv plane, this is what the new picture looks like. And I erroneously integrated from 0 to 1 for both u and v, but it isn't. You can see from the picture that v equals 0 is the bottom, but the top is v equals 1 minus u. And then u is going from 0 to 1. And u comma v is like x comma y. Then the Jacobian was 3. Partial of x with respect to u is 2. Partial of x with respect to v is 1. Partial of y with respect to u is 1. Partial of y with respect to v is 2. 4 minus 1 is 3. So it should be the integral as u goes from 0 to 1, v goes from 0 to 1 minus u of x minus 3y. There's x, 2u plus v, minus 3 times y, u plus 2v, times the Jacobian, dv, du. Okay, so this is still correct. I took the Jacobian 3 out. 2u minus 3u is a negative u. V minus 6v is a negative 5v. Okay, it's easy if you factor out the negative 1. So negative 3, I like integrating u plus 5v. So that's uv plus 5v squared over 2. As v goes from 0 to 1 minus u, plug in 0, you get 0. Plug in 1 minus u, you have u times 1 minus u plus 5 over 2, 1 minus u squared. Okay, and the easiest way to integrate is to not do a substitution. I thought that was too clumsy. Just distribute u minus u squared plus 5 halves. 1 minus u squared is the same as u minus 1 squared. Okay, 1 minus u and u minus 1 are opposites. Therefore, when you square them, you get the same thing. So it's easier to explain it that way. Now I integrate u squared over 2 minus u cubed over 3 plus 5 halves u minus 1 cubed over 3. Okay, so if I plug in 1, this becomes 1/2 minus 1/3, and that becomes nothing. So negative 3 is in front, 1/2 minus 1/3 plus nothing. And then if I plug in 0, that's 0, that's 0, but that's not 0. That's going to be 5/6 times negative 1 cubed, which is negative 1. So I have 1/2 minus 1/3 minus a minus 5/6, which is 3/6 minus 2/6 plus 5/6. This is all 1. So it's negative 3 times 1, or negative 3. So the solution should be negative 3 to 15.9, problem number 13.